Good evening. Today, as a practice, I thought we'll go through the sample assessment paper. Some of you may have tried it already, since after Unit 1, I know majority of you might be a little depressed. It doesn't matter, just forget about it. We'll focus on Unit 2 and give you your best. I'm pretty sure most of you will get the grades that you deserve. All right. Now, if you have already solved, then you can skip this video. If you haven't, MCQs I'll just go through. I will not give you the answers now, but then you can pause the video, try it, and after this session, at the end, I will show you the answers for the options. MCQs. Then you can check your answers. All right. We'll straight away go to the structured questions. That's question 1. You can pause the video, attempt it. Question 2. Question 3. I'm sorry, I'm not able to fit the entire option. Right. Question 3. Question 4. Question 5. Question 6. 7. 8. Yeah, actually on the x-axis for current. 9. And 10. Question 11. An airport uses the pulse echo technique with radio waves to monitor the positions of aeroplanes. These radio waves have a wavelength of about 0.1 meters. So information is given 0.1 meters. Then you've got state what is meant by wavelength. It's just 1 mark. You might be thinking it's easy. Yes, it is easy. But the definition that you have learned in IGCSE is wavelength is the length occupied by one complete wave. But I would say for Edexcel or for AS level, please write this definition, which says it is the distance between two adjacent points which are in phase with each other. So the distance between two adjacent points which are in phase with each other. Now here this term is very important when you are saying in phase with each other. Please try to use these terms and then try to score the full mark. All right. Now determine whether a pulse of duration 1.5 microseconds would be suitable to monitor the position of an aeroplane at a distance of 60 kilometers from the airport. So the distance from the airport to the aeroplane is 60 kilometers. So what you need to do first is calculate the distance of this pulse, how far it will reach in this 1.5 microseconds. The formula is straightforward. V is equal to distance over time. You calculate that. But one thing here is the unit. This is 1.5 microseconds converted to seconds. So into 10 to the power of minus 6 you need to substitute, and speed will be 3 into 10 to the power of 8 meters per second. So you've got that, and so you'll get the answer in meters, right? So that, because the wavelength is also in 0.1 meters. All right. Now when you substitute, you get this answer. So a distance will be velocity multiplied by the time taken. As I said, 10 to the power of negative 6 you have to substitute. You get 450 meters. What's this? This is the total distance to travel back and forth. So half the distance would be, you get 225 meters, which is much less than the distance that is required. Hence, it is suitable, right? Now, the last part of this question is the radio waves are emitted. You can read it, pause it and read. I'm just skipping that. Now here, what's given? Intensity is given and cross-sectional area is given and power is asked. This is again a straightforward substitution of power and power intensity and area of cross-section. As you know, the formula will be I is equal to watts. Okay. Again, be careful with the unit, it must be in kilowatts, because you've got the intensity to be in kilowatts, and meter square will get cancelled. So you get the power in 2.1 kilowatts. That's question 11. I suppose that was an easy question. Now, coming to this question, it's an asterisk question actually. The asterisk is not shown. Question 12 is an asterisk question, and it has got 6 marks. And we have, as I have been telling you earlier, these type of question, they expect you to write the answer in a coherent and logical manner. You need to have link from one point to the other. So try to secure or make sure that you have written 6 valid, logical, sequentially arranged statements. All right. Now here, what would be the first point? See, you're supposed to write about, discuss why black lines appear on this spectrum. Now, the first point would be, you have to definitely start about writing electrons. So the atoms in the atmosphere contains electrons. That's a very simple statement, but it is a fact. So you have to mention that. That's one point. Then second point would be, electrons will, what will these electrons do? They will absorb photons from the sunlight, right? Of course, these electrons will be absorbing photons, but will all these photons be absorbed? No. Electrons will, after absorbing these photons of energy, they will move to a higher energy level. But will all these electrons move to a higher energy level? No. So the energy levels are discrete. So only certain energy levels, if they absorb, they will be moving to a next higher level. So then the next point would be what? The energy of the photon must be equal to the difference in these energy levels, right? So only those electrons will move up to a higher energy level, and there are only limited number of energy differences available. Hence, you get a limited or a fewer number of black lines. I hope that's clear. I'll try to include the 6 points here. So you can write it down, after listening to my explanation, try to write down all those points and then check whether you've included the expected points, right? Answers for the MCQ multiple choice questions. You can pause it and then verify your answers. All right. Now the continuation of this will be in another video. See you. Bye.